Hello, everybody. Welcome back to Carabed Science Lessons. Today, we're going to be talking about satellites. So make sure that you remember all that you learned about gravity. We're going to be talking about that a lot today. So, what is a satellite? Satellites are objects that use gravity to orbit around a planet or star. So satellites are things out in space that are caught by a gravitational field by something big. So, planets or stars, they have a lot of gravitational force, right? They like to pull things into them. So some things get caught in that pull and start to orbit around that big planet or star. And being in orbit means traveling in a path around something else due to gravity. So the sun has planets that move around it, right? So those planets are in orbit around the sun. They move around and around and around. Sometimes it's a circular path, sometimes not. As long as it's moving around it due to gravity, that means it's in orbit, and therefore it is a satellite. So what kinds of satellites are there? There's two main types. The first one is natural satellites, and the second are man-made satellites. And we're going to be talking about both today. So remember these. First up is a natural satellite. So natural satellites are things that are orbiting just like a regular satellite, but the reason that it's orbiting is that it's because of nature or natural events. So nobody put it there in specific, it just happened to occur because random things happened in nature. So some examples of this would be the moon to the earth. So you know that the moon travels around the earth in orbit, right? It goes around and around the earth. And nobody put the moon there in specific, right? We didn't choose to take a big rock and throw it out into outer space until it got caught in Earth's orbit. No, it was already there because of natural events. Random things happen in space, things crash into each other, and it just so happened that the moon was in the same place as the Earth and it started to orbit. Therefore, it's a natural satellite. Just like that, the Earth to the sun is a natural satellite because nobody put the Earth in here in specific to rotate around the sun. It just happened because of natural events. And then finally, we have meteoroids or asteroids, which those are small rocks that are floating around in space. They can be big, actually, or small, but they're floating around in space and they get pulled on by a planetary or solar gravitational field, and they start to also rotate around in orbit. So all of these are examples of natural satellites. Moving on to the moon and Earth as satellites, this is something that you probably already knew, but you didn't even know that they were satellites. The moon takes 28 days to complete its orbit around the Earth. So one full path around the Earth takes the moon 28 days. You know what else is 28 days? If you said about a month, you're correct. It takes about a month for the Earth to have the moon rotate around it one full time. So we start off with a full moon, and then we go into a crescent, and then a new moon, and then it comes all the way back to a full moon. That's one full orbit of the moon as a natural satellite to the Earth. And then another example is the Earth to the sun. Remember, we talked about this. It takes 365 days for the Earth to orbit around the sun. What else is 365 days? If you said a year, you were correct, because it takes one whole year for the Earth to complete its orbit around the sun, making the Earth a natural satellite of the sun. Now let's talk about man-made satellites. So the biggest difference between man-made satellites and natural satellites is that they're man-made. So humans make these satellites and purposely launch them into orbit and keep them going around and around planetary objects for different purposes that we'll go over later. But some examples of this would be, rockets. We launch rockets from Earth to travel around Earth and sometimes come back or crash or do whatever. But we make sure to launch them into the gravitational field of Earth so that it can keep rotating around Earth if we need it to. And then also we have the International Space Station, which is a really big satellite. That's what's in this picture right here. These are all solar panels, and there are little tunnels and pads in here that scientists and astronauts live in. And the International Space Station was made by a bunch of countries that came together to create a big satellite that can work for all of them and collect data. But you might be thinking, what is even the point of making satellites? I mean, they're natural satellites. Why do we have to make them? There's a lot of reasons, and some of them we'll talk about right now. One reason is to see the Earth from space. So I'm sure you've seen these beautiful pictures of Earth, like as a globe. Even right here, you see this curve right here. All of this is where we live. This is Earth, but you're seeing it from outer space. And to get those pictures, they put cameras onto a satellite before they launch it, and then they can take pictures from there and send it back to Earth so we can see. And more than just having a cool picture to look at, this is important in predicting the weather. So you see these white clumps here, those are all clouds in the sky. And we use this information in these pictures to predict whether it's going to rain or how fast the winds are blowing. All important information that you use day to day, like what are you going to wear today? Can we go skiing today? You know, things like that. And then also, sometimes satellites are used to see into outer space instead of back down to Earth. So imagine that you wanted to see a constellation or you want to see the stars, but it's not dark enough on Earth, or maybe it's cloudy and you can't see it. Well, scientists that study space need to see space all the time, right? Just because it's raining doesn't mean they can stop working. So they use satellites that are above all the weather, above all of the interference that we experience on Earth, so they can see into outer space. And then also, you might be using satellites without even knowing them. Whenever you make a telephone call, signals are sent from your phone out to a satellite, and then that satellite redirects that signal to somebody else's phone. So then you can communicate with them, but the whole time you're using a satellite and you don't even know it. And then there's also the Global Positioning System, or for short, we call it GPS. That's how to find out where you are on a map. So when you pull up Google Maps and it tells you that you're in a specific location, how does it know that? There's a satellite out in space that is sending signals to your phone and receiving signals from your phone, and it can tell exactly where you are. Isn't that cool? Well, I think it's really cool, and I really hope that you guys learned something. Let's test to see if you did, though. Let's go over this example problem. The relationship between the Earth and the Moon is that A, Earth is the Moon satellite, B, Earth gives the Moon light, C, Earth spins around the Moon, or D, Moon is the Earth's satellite. I'm going to wait a few seconds. You can pause it if you want to think about it, but try and answer this on your own. Okay, I'm going to switch the slide in 3, 2, 1. If you answer D, you are correct. The Moon is the Earth's satellite. That is how they are related. Remember that a satellite is something that orbits around something else due to gravity, and the Moon orbits around the Earth. Therefore, it's a satellite. An extra bonus points if you remember that the Moon is the Earth's only natural satellite because nobody put it there, right? It was naturally there. A and C are wrong because the Earth does not spin around the Moon, so therefore the Earth is not the Moon satellite. And B is wrong because the Earth does not give the Moon light. The Earth doesn't actually give off any light. The sun gives off light. Let's do another example problem. Which is a natural satellite? Is it A, the Moon, B, star, C, the sun, or D, a meteorite? Again, try think on this on your own and try answer by yourself. I'm going to show the answer in 3, 2, 1. If you answered A, you are correct. A natural satellite is the Moon. We talked about the Moon being a natural satellite for the Earth, right? Because it rotates around the Earth in an orbit. But if you answered B or C, think about that, because the stars usually have a really strong gravitational force. So the sun and a star usually have things orbiting around it. So they have satellites, but they are not natural satellites themselves. And then lastly, for D, if you answered D, that was a tricky one. I almost got you there. Because when I talked about natural satellites a few slides ago, I said that meteoroids or asteroids were also natural satellites, right? But meteoroids and meteorites are not the same thing. Meteoroids are rocks that float around in space in orbit, and meteorites are those rocks that have fallen down to Earth. So that's an important distinction. If it's fallen down to Earth, it's not really in orbit anymore, right? So it's not a natural satellite. So it's not D, it's not C, it's not B, it's A. So congrats if you got that right. But thank you again for tuning in. I hope you all learned something. And if you have any questions, make sure to email info@caribed.org or message us on WhatsApp. Have a great day.